Good afternoon, everybody, and good morning. I'm just going to wait for a couple of my team members to join in on the call here. I want to make sure that they are at their desks at their webcam. And there they are. Good morning, everybody, and good afternoon. Firstly, I want to thank everyone for taking time out of the day to join the Ultralife and Excell. This is now our second roundtable webinar. So we decided to run this one back and change up the topic. So as you can see in the topic here today, we're going to be reviewing remote monitoring and asset tracking applications and some of those challenges and solutions that we can review throughout the next half hour to 45 minutes or so. So you can see I had called in our panelists there in the first minute. Today we have three team members from Excell and the Ultralife family. Firstly, we have Eric Lind. He's the VP of Commercial Operations at Ultralife. We as well have Craig Semple. He is the general manager out of our Calgary manufacturing facility. And additionally, we have Mike McWillie. He is the director of engineering for Excell Battery Company. And then myself, I will be the quarterback of today's webinar, and I am the sales rep for the eastern side of the Canada and US territory. So without further ado, to keep everything on schedule here, we have about 5 questions our panelists are going to review. They're each going to answer and provide any side comments the team has throughout the day. So next question there, Mars. Before we do move on, we do have a Q&A throughout the webinar, so feel free to ask any questions, and we will review those at the end of the webinar. So let's jump right into it. Question 1. What are overall trends we are seeing in remote monitoring and asset tracking applications? So what I'll do is I'll send this one to Eric to start, and Craig and Mike, please feel free to chime in after the answer.
Yeah. Okay. Thanks a lot, Charlie. I appreciate it. So, one of the things, remote monitoring and access tracking applications, they can be very different. Sometimes they're kind of grouped together. But when we take a look at remote monitoring, kind of what we look at is what's happening really on the kind of industrial side and the medical side. That's where we see kind of two big trends or two big markets for this. On the remote monitoring side, we kind of broke this down both in the industrial and the medical spaces as kind of those two areas. And really in the industrial space, what we are seeing is a lot more of the kind of IoT sensor applications that are being developed to allow companies to kind of remote monitor systems that, in terms of in like manufacturing environments, those sort of things. But a lot more of the kind of IoT sensor applications and introduction of that, and then being able to remote monitor that, outside, not right there. There's always been some sort of remote monitoring. We've seen that in metering historically, where you have meters that basically send data to people to kind of understand water usage and gas usage. That's always been there, but now you're beginning to see a lot of this happening in for to understand kind of health of the systems. In the medical space, it's kind of in the remote monitoring side. It's really kind of in two different areas. You see kind of the rise of telehealth, where doctors are getting patient data from remote systems and kind of so that people aren't coming into the hospital settings. But you also see internal stuff happening in the in hospitals. And really what's exciting about that is just a lot of the sensor development that's happening to look at EKGs. You look at kind of some of the other health types of measurements that are being made on patients. And things that they're moving to, which kind of really begins to kind of tax some of the battery requirements, and really gives some innovative ways to power those kind of systems. On the asset tracking side, it's really companies that are looking to find more and more about where their assets are, both inside and outside. We see a lot of it in hospitals to understand where medical carts are going and really asset tracking, in there. We see an expansion, in settings in the wireless network and the upgrades of that, so that that things don't get lost or stolen. We also see, in the asset tracking side, much more development in terms of understanding kind of state of health of systems, whether it's the system itself or in our cases, the batteries. And that can be kind of fed to kind of a remote site where that you can do kind of proactive maintenance on systems. When you begin to look in terms of larger types of systems and larger types of asset tracking, kind of outdoor stuff or large kind of warehouse stuff, you're beginning to see some really innovative things where there's, the potential. One example is using drones inside warehouses or outside in kind of larger industrial systems to basically understand where things are on a map. Those large systems, it really kind of takes away people needs to be able to do that. It saves costs. It allows the ability to work kind of 24 hours a day to track systems and really help kind of secure different things out in some of those environments. And I think those are, and each one of those have very different needs from a battery standpoint, where we take a look at the environment, we take a look at what some of the what some of the needs of the application are, and really kind of use kind of different battery technologies to be able to power some of those systems.
That's a great answer, Eric. Craig, I saw you unmuted there. Did you have anything you wanted to add on to that there?
No, I don't think. I think Eric's got a pretty good handle on that one. It sounded pretty great.
That's what I thought. Yeah, that was a great answer. So we'll just move on to question number 2 then. So question 2, what are the limitations of the available battery chemistries, and which one is right for my specific application? So Craig, since you're unmuted, I'll hand this one to you.
All right. Well, I mean, there's a pretty big scope of question there. Remote monitoring, we're getting off and out into a wide range of environments, like Eric was talking about. There's a lot of stuff kind of happening indoors in that sort of that space where we're trying to see what's happening with various assets around our own buildings. But more often than not, a lot of the really challenging stuff that I see is the stuff that's out in the world, right? It's out in the middle of nowhere. So we get really into these challenges around the temperatures that you're situated in, cold especially, and hot. But temperatures, they have the biggest effect on a lot of these chemistries and what you're able to get out of them. We go back to the old rule of thumb of chemistry. Every 10 degrees Celsius you go down, you have your reaction rate, and so you're putting more and more pressure on a lot of these systems as things get colder. Out in your world, you may have a big issue with your access to getting personnel to site. You could have things around your access to sun and solar, and so we look towards rechargeable technologies and the lithium rechargeable family, which is today there's a whole host of them. Most commonly, we sort of see the NMC family and the lithium iron phosphate type of products. They typically have good charge acceptance for solar, but the flip side is they often really don't like a float charge or being stored at full charge. And so you kind of have to weigh that when you're trying to see if you can get these things recharged somewhere in a remote, far-flung area. You can have some physical robustness issues. If you get towards sort of the lithium polymer end of the spectrum, they just don't have that mechanical ability to hold up to strain and stress as much as some things that have some more mechanical bits to them. Your temperature window in these lithium rechargeables is usually down as low as about -30 and up reasonably as about 65 degrees Celsius for operations anyway. But we certainly see the problem comes in when we try to charge things. Very few of these chemistries are going to be able to charge sort of below freezing. And so we usually need to keep them in the 0 to 45 when we're trying to charge, which definitely presents some issues for those people trying to do some remote charging type of applications. Other rechargeable technologies we get into, some legacy systems like lead acid. It's kind of tried and true. And there's some really good stuff still out there where there's pure lead with spiraler wound anode cathode materials, which are really great. They're physically large, very low energy density, but really quite robust and can take a charge at fairly low temperature. But if you have to get out on a helicopter deployment and go out into the middle of nowhere, you don't want to be taking all these very, very heavy batteries. There's nickel metal hydride, which has been around forever. Low cycle life, high self-discharge, pretty good for a solar, but temperature stuff, it also doesn't like those low temperatures. We get a lot into the primary type of products where they're not rechargeable, but they have very, very high energy density, and so they're going to last for a long time out in the field. Their current delivery is typically lower than your rechargeable type products, but that very high energy density is a lot of what people are after. And they've got a fairly good swing in temperatures, often down to as low as -30 and up to about 85 degrees Celsius. There's products that go as high as 200 degrees Celsius. So a lot of a range of applications can be covered in those temperature world, but they cannot be charged. So that you can get into sort of a dangerous element. And you're also, anything with sort of lithium in the name these days will be in that dangerous goods world. So that also adds another element for you. But for the most part, we're out in the cold. And so something that's become quite common for remote monitoring, especially, is to pair something like a lithium thionyl chloride cell, which has very high energy density, with the pulse capability of like a supercapacitor. And so you can often marry those two worlds of really good energy with the ability of a supercapacitor to get you that good pulse. So that works fairly well when you're trying to transmit under like a satellite condition or GSM, where you need to get a pulse out and then you're going to go back to sleep for quite a while. You can often get the benefits of both in that kind of world. So, overall, our biggest hurdle is typically often around that temperature stuff. I've seen some fun ones over the years. I had an application not too long ago where they were measuring ice flow in the Arctic. And sometimes it's just clever deployment that gets you past a lot of things. In this particular one, they bored a hole through the ice sheet down into the ocean water and put a pipe kind of tube that the battery actually sat down in the actual liquid water underneath the ice sheet. And so in that case, it would never change from about -2 Celsius, which was kind of a clever way to not deal with the absolute extreme type of temperatures that you see, and still get a pretty good pulse in an extremely remote environment. When we come to which one is really right for my application, that's a very multi-dimensional sort of problem. And the first really thing you're going to get to is that you want to know where your goalposts for your application really are. It's really important. Folks like us can always help with that narrowing down, but you really have to understand your regulatory environment, what requirements you're going to need to meet there, what energy budget you need, like what sort of power and energy will you need this thing to last for. What kind of current and power delivery will I need? Am I going to run Wi-Fi or GSM or satellite or Bluetooth if it's something a little closer together? So knowing what your nominal currents are and what your pulse currents are is really important for narrowing down what chemistry is going to do the right job for you. Obviously, of course, as I spoke about, you're going to need to know, what spec are you going to want on your product in terms of your environmental world. So the temperature, usually the most important, but there's other things like shock and vibe. Will it be directly in the sun? All these sorts of fun stuff. So there's a lot on which is right for my application, and you're best to have a conversation with folks such as ourselves to really help you narrow down that world.
Right. You know what I was just about to say, and that's a great way to finish there. If you guys are unsure, please reach out to us. We're happy to help you guys. So, Craig, I think you answered that one very in depth and well. So I don't know if we'll start with the question 3 here, and then get some side comments going here, just so we can stay on time for everybody. So question 3, how do I design for an application with limited space? So we'll go with the guy we haven't heard from yet, our director of engineering. We'll go with Mike.
All right, my turn. All right, so this one can be a bit of a challenge, but if at all possible, it is it's usually best to design around commonly available cell sizes. Limited space means you're going to be looking for high energy density. If it's rechargeable, trying to design around lithium ion, either NMC or lithium iron phosphate cells. Cylindricals are the most commonly available. NMCs, that would be like 18650, 18 millimeter diameter, 65 millimeters long. Cylindricals for iron phosphate, so generally a little bigger, kind of 26 millimeter diameter, 65 millimeter long per cell type sizes. If the thing is small and that's way too big, not even possible, you're not out of options. There are pouch cells, which can be an option for both primary and rechargeable. Sometimes called polymers as well. Those are available in all kinds of form factors, and they can be quite thin, which can be a pretty huge advantage. The challenge with those is because they're in a pouch rather than a metallic can, they have to be properly constrained such that as they age, they'll expand, and you don't want them expanding into something that's going to puncture the pouch or cause some other kind of hazard. A lot of this gets easier if you do it early in the design cycle. So we often find that the battery can be a bit of an afterthought, and if you are able to start thinking about that right at the start before you've designed enclosures, tooling, and so on, you'll have a lot more options to find something that fits exactly what you need.
That's great. Eric, I saw you unmuted there. Did you want to chime in?
Yeah, I think, Mike did a great job of kind of explaining, just some of the limitations on applications that are kind of out there. I think as battery people, we always find that, as we have some discussions with customers, that they essentially, want the battery, the kind of three things. They want it to be infinitely small, last forever, and cost nothing. Right. So, we have a hard, that's a difficult role to kind of achieve, or a difficult goal to kind of achieve. But yeah, again, with limited space, for an application, one of the things obviously is we begin to take a look at new systems and new products coming in place. That gives an opportunity to look at that. While it doesn't have to do with remote monitoring, one of the big trends that we see is, in the increase in data centers and the amount of capacity that are in data centers that are taking up more power, but are really cited for kind of these large lead acid systems. That's an opportunity for lithium ion or lithium iron phosphate to kind of come in and replace that as for large energy storage systems that will then give you energy to kind of to kind of that for the energy needs that you have for these data centers, while also kind of fitting within the space. I mean, so, there are limited spaces in kind of handheld devices and smaller devices, but even when you take a look at larger things, you see new and advanced technology beginning to help some of that.
Yeah, that same line of thinking also applies to the telco world as well. There are
exactly
tower deployments everywhere with 48-volt lead acid systems that there's no more room in the cabinet, but we need more energy. So iron phosphate's a fantastic fit there.
That's great. Thanks, guys. Thanks for that input. Marcel, we'll go to question number 4. So here we are. What are the regulatory considerations I should take into account? Eric, we just heard from you, but we'll send this one back to you again if you want to chime in here. And feel free, Craig and Mike, any side comments you have, feel free to jump in.
Yeah, thanks, Charlie. I mean, I think there's just with any batteries, particularly on the lithium side, I mean, there's always regulatory things that you have to do that need to be considered. One of the big things that for lithium batteries is what they call the UN transportation regulations. And this regulates how you're able to kind of ship batteries back and forth, from one location, basically because of the amount of lithium content in there. And it's very stringent in terms of what these products have to, kind of pass to be able to, to be able to be shipped properly. This is why, some of the design works and, going, with a good battery company is really helpful. But then, a lot of times what we work with is that, we work in a lot of different applications when we think about, medical, industrial, oil and gas, government defense, and each one of these have different battery requirements. A lot of the, medical and industrial applications have some other safety requirements in terms of just some of the design pieces of the battery itself. So IEC 62133 for some of the battery packs and different iterations of that. You have some UL certifications, the 2054, as well as a similar UL specification for safety that are important. There are also certain countries that have requirements. So one of the things that you have to kind of take into account is being able to, if you plan on shipping a product or something like that into India, a lot of times, for example, they are looking for what they call kind of the BIS certification. And this is a very Indian specific requirement that essentially ensures that the battery pack or battery system will meet some additional safety requirements, performance and safety requirements. So really, as you begin to look at, the design or the development of battery systems, whether it's an off-the-shelf system or something else, or a custom system, really what you want to make sure is that based on what your application needs are, that the appropriate certifications are done. And frankly, a lot of these are driven by the devices that it goes into. And I think that's important, for us as a battery manufacturer and battery designer. What we want to be able to do is really understand as much about your application and locations that it's going, so that we can make sure that we design it appropriately, and that it'll meet your needs. Again, some of the work that Excell does, particularly in the oil and gas and industrial environment, can be extremely have some extremely stringent environmental requirements. And having an understanding of what your needs are is kind of critical for some of the battery design piece of this.
Great, Eric. And just to add on to that, we will help you out through all your regulatory certifications, and we will actually go through them with our test labs for you as well. So if you do have any questions in regards to your current product or new battery packs you guys are developing, we are very familiar with the certification and regulatory companies that we are able to go through that process with you guys. So we'll go to question number 5, which I think is our last question. We'll go back to this at the end of the webinar. This will bring you to the Excell website where we can review, or where the QR code will bring you to that ATEX and HAZLOC portion of our website. So that's just a little side piece of information for everybody there. Question 5, and we'll finish with Craig there. What sourcing, procurement, and supplier considerations should I take into account for my battery packs?
Yeah. In these ones particularly, a lot of remote applications often have that really high cost of failure associated with them. Getting personnel to site can be difficult to schedule, time and money issues around that. So robustness really becomes the key in a lot of the folks that we work with. So when we're looking for a lot of that, you want to work with suppliers and manufacturers of cells that have experience in these applications. I mean, they're going to design for the environment you're going to be working in. They'll perform verification testing to your specific environment. They'll know from all the depth of experience and applications they've seen the best fit solutions with components that aren't going to quit on you. They should have access to, ideally, have internally tested a lot of the cells, a lot of the components themselves. Excell, for example, I mean, we have extensive relationships worldwide that really let us enjoy a great number of suppliers and options that don't limit the customer to a narrow offering of products. you know, the supplier needs to be able to understand your regulatory environment you're going into. It's always great if the cells and components can be pre-tested to be compliant. Something maybe like IECEx, where you want to hit, say, the T4 test, you don't go above 135 on a short. And several products will have been already tested to that, if not have a little stamp that says they're compliant to that. So it's always good to have suppliers that can go in that direction and already have, you know, known a lot of the application types of things that you're going to be after. Beyond those sort of things, you want to aim for common form factors whenever possible. I know Mike brought that up. I'll bring it up again. You know, don't paint yourself in a corner. If you get a 18650 type cell, there's many offerings. You can, if your cell somehow goes obsolete or end of life, you can move on to another very similar cell with very little pain. If you get kind of designed in on something that's very specific, it can be a lot of trouble to get past that. And if you've got regulatory things that you've already worked through, it can amount to a lot of cost in dollars and cents. So, you know, having suppliers that have a great relationship with, you know, their upstream suppliers and can help you see and spot things like end of life really early is very helpful. Another thing you might really want to think about is, where is it going? I know Eric just brought it up. Where will your product be going? Because you know, if it's, say, going to India and has the BIS, or if it's going to, say, Saudi Arabia, has the Sabre system. So you want to know that when you're designing and getting products that are going to be angled towards specific environments, that they're going to be able to meet the stringent environment of the various countries that it's going into.
Along those same lines, there are maybe a few more things you can consider for supply chain risk mitigation. Some of the tests that we had talked about earlier, you know, IEC 62133, UL 2054, several parts on the BOM there will be classified as critical safety components. So if you can spec an alternate at the start for things like thermistors, FETs on the BMS, your life will be a lot easier if you need to switch those at some point, because they're already pre-certified. You can just drop it in. Otherwise, you have to go through a partial retest to those standards to prove that the new parts meet the requirements.
Yeah, and just to add on to something Craig said about requirements and where it's going, it kind of jogged my memory in terms of there's now in Europe, for example, there's a new requirement that all batteries have to be CE certified. Now that's a certification that we can do and we have done, but if you're even take a look at some of your existing products that are going into and your battery suppliers that are going into Europe, having that CE required now is now becoming a requirement, and the companies, you know, battery companies are kind of working towards that. So you want to make sure that anything that you specify moving forward from a procurement or sourcing kind of area, when you give a battery supplier, you know, kind of a specification, or kind of work through the specification, that some of that information is in there.
That's great. Thanks, guys. So that's it for question 5. I think the next slide might be the Q&A. So we only have 2 questions here, guys. So what I'll do is,
we must have really covered things off.
Exactly. I'm gonna send this one. I'll send this back to Eric, and I think the second one might be for Mike. How does temperature influence the choice of battery?
Well, yeah, I mean, I think, you know, the battery chemistry systems, different battery chemistry systems have different temperature requirements. I mean, virtually all battery systems will work well at room temperature. But as you change temperatures, whether it's going low or going high, you will have different performance characteristics, as well as, you know, even potential different safety aspects of that. For example, is that there are some primary technologies that will operate better. Some of the thionyl chloride will operate better at the, you know, extremes, at the, you know, plus 85 or even higher in some of the oil and gas kind of applications, but also down to kind of minus 40. whereas maybe a manganese oxide application will kind of be kind of a shortened kind of temperature window. So that's, I mean, that's, you know, that's how kind of temperature impacts it. It also, the temperature kind of impact, particularly in rechargeable batteries, can impact cycle life, you know, the number of cycles that you're getting out of that, or the heat that's, you know, that you're applying to it will impact longevity of the application. So, and then just even within chemistry systems, what you find is that certain designs by certain suppliers will give you better performance or different performance, right? So again, it's one of those reasons, as you know, I know Craig and Charlie had mentioned in here, is, you know, working with a, you know, an Ultralife or an Excell or something like that really allows you to work, you know, basically to take advantage of the experience that our companies have in having designed this kind of work in. You know, I like to say, anecdotally say, is that you know, there's a lot of different stuff that's out there, and it can be, you know, all of this can be very overwhelming at times to try to select the right things. But, you know, we look at it, you know, I look at it anyways, different chemistries, and all these things are kind of arrows in my quiver. And listening to kind of what customers want, both in terms of both from a technical side and even from a business side, you know, allows us to kind of select the right thing that will address those needs.
Great, Eric. Thank you. And then the second question here, Mike, I mean, Craig could take it too, but I'll send it off to Mike, is when we talked about primary batteries, the difference between a bobbin and a spiral cell.
Okay, yeah.
And when to choose which.
Okay, the difference is really, it comes down to the way that the electrodes are wound internally. The trade-off there is capacity versus discharge rate capability. So bobbins have much more capacity, but at the expense of discharge rate. So you might get, you know, 20-30% more capacity, but say for a D-size cell, be able to only discharge at a peak of a couple hundred milliamps, where the spiral goes the other way, where you get less energy, but a much higher discharge rate, like say 2 amps out of a D cell, 10 times the discharge rate. So really that is the trade-off you're playing with, capacity versus rate. And Craig kind of hinted at it a bit earlier, but you can kind of get the best of both worlds if your application has kind of a low background current, but large pulses with the super cap. So you pair that super cap with the bobbin cell, that gets you a lot of capacity, and then the capacitor takes up the pulse.
Great. Craig, I saw you on mute. Did Mike take your answer there from you?
Yeah.
Sorry.
No, that was great. And I mean, I think Mike also in the question, it's really important to match. I mean, aside from say a supercapacitor add-on, it's really important to match sort of your application's current with that spiral bobbin, or even a moderate rate, more moderate rate cell, because you will, you know, even if you could use that bobbin cell in a higher rate application, there's a good chance that you will actually realize more capacity from that high rate due to phenomena like cathodic freeze over and things like that. So it's really important that you speak with folks like us, and that you really know your application in terms of what kind of current and power you need, so that we match the cell right that's going to get you a safe, high energy solution that's going to get your sweet spot.
Great. Thanks, Craig. So that's the only 2 questions we had. My email will be at the end here, so if you guys do have any for any of the panelists too, I will forward that question to them, and we'll get that answered. But Eric, here, I'll bug you one more time to unmute if you want to break down some of the Ultralife locations here.
Yeah, just, I mean, you know, Ultralife, you know, we're a publicly traded company. You know, our headquarters is in Newark, New York, which is halfway between Rochester and Syracuse. This map just kind of gives you shows you a very wide spectrum of what Ultralife and our subsidiaries have in terms of manufacturing capabilities on a global basis. You know, so we have operations in Asia, in Europe, and several different manufacturing locations here in the United States. And you know, and all of our facilities are ISO 9001 and 1345 certified. 1345 certified is obviously a medical requirement. It really looks at kind of traceability of products throughout the manufacturing process, so you can understand what components go in those batteries and be traceable for that from a regulatory standpoint. And then 9001 obviously is the quality standard. But you know, it's working with again, you know, I sound, you know, I know I sound like probably a commercial, but that's one of the benefits that you get with working with somebody like us is, you know, we can take, you know, we have a variety of technical and manufacturing resources across the board to not only satisfy, you know, to get your performance needs and develop a product, or even you know, recommend a product that we have that will satisfy those performance needs, but also address some of the business aspects of it as to kind of where's, from a sourcing standpoint, from a manufacturing standpoint, and then just really looking at the entire business model from you know, from concept ideation and things like that, all the way through design, development into production, and then being able to have areas where we can kind of help support across the board.
Perfect. Thanks, Eric. And then next slide, please, Marcel. So there's my email. I just got my email there. We didn't want to cluster it with too many ats and too many names. So if there's a question for any of the panelists, please just reach out to me. I'll get you in contact with them. And then what we'll do to close off the webinar, I think, is we'll leave that QR code up so you can feel free to go to our website and check out our white papers available there. So once again, thanks Craig, Mike, and Eric for joining in today, and I hope everyone was able to get something out of the webinar. And once again, please reach out to us with any questions or any needs that you have. We're happy to help. Thanks again, everybody.